Welcome to Eternal Vault, where we explore the deepest mysteries of our universe, the hidden stories of science, history, and the human journey. Tonight we turn our gaze not upward to the stars, but downward to our own world, Earth itself. Go outside on a clear night and look up. You'll see it, the moon. Its face is a cosmic battlefield, scarred by billions of years of relentless bombardment. Every single pockmark is a permanent record of a collision from the deep past. The moon is a frozen museum of violence, dutifully recording every major blow it's ever taken. But our world? It tells a very different story. Look around you. Rolling hills, sprawling forests, vast oceans, mountain ranges. A dynamic, vibrant, remarkably smooth planet. Yet Earth was right there, in the same cosmic shooting gallery as the moon. With over 80 times more surface area and far stronger gravity, it was a bigger target. Earth should be utterly obliterated with scars. And yet, we only know of about 200 confirmed large craters. So where are the missing craters? This is not just a question of geology, it is a question of identity. To understand why Earth looks so clean, we must unmask the three great forces that erase its scars: the atmosphere, erosion, and plate tectonics. Along the way, we'll see how scientists around the world, from India to Europe, from NASA to Russian geophysicists, have hunted for the ghosts of vanished impacts, and how this mystery tells us something profound about what it means to live on a living world. Let's begin the investigation. To grasp the mystery, we must travel back to the violent birth of the solar system. 4.5 billion years ago, our sun was young, surrounded by a swirling disk of gas and dust. From that disk, the planets coalesced, but they weren't alone. Billions of leftover fragments, asteroids, comets, planetesimals, orbited chaotically, smashing into anything in their path. The early solar system was no peaceful nursery. It was a cosmic demolition derby. Then came the late heavy bombardment, around 4 billion years ago. For a few 100 million years, the inner planets were battered by a rain of impacts. Mercury, Venus, Earth, Mars, all took hit after hit. The moon, locked in Earth's orbit, was pummeled as well, preserving the scars we still see today. But here's the statistical puzzle. Earth is 4 times wider than the moon and has a gravitational pull 6 times stronger. That makes Earth a cosmic vacuum cleaner. Models suggest Earth should have taken at least 20 times more hits than the moon. For every crater on the moon, there should have been dozens on Earth. Now imagine just one of these impacts. Picture a rock 2 kilometers wide slamming into Earth at 20 kilometers per second. That's about 72,000 kilometers per hour. The energy released would dwarf every nuclear weapon on Earth combined. We're talking millions of megatons of TNT, enough to boil oceans and set forests aflame worldwide. Such cataclysms didn't just happen once. They happened thousands, maybe millions of times. Earth should be a planetary punching bag, its face shredded with scars. Yet when we look around, we see hardly any evidence. The question deepens. Where are Earth's missing craters? Before an asteroid can touch the ground, it must survive Earth's atmosphere. And that atmosphere is not passive, it's violent. Every day, Earth is struck by about 100 tons of cosmic debris, pebbles, grains of sand, chunks of rock. Out in space, they are meteoroids. When they enter our sky, friction with air molecules turns them into meteors, shooting stars. If they survive, they become meteorites. But most never make it. Traveling at speeds up to 72 kilometers per second, a rock compresses the air in front of it into a shockwave so intense that the rock itself ignites. Ablation strips it away layer by layer until it explodes in a brilliant flash. A pebble vanishes in a blink. A boulder glows like a flare and vaporizes. Sometimes, as with the Chelyabinsk meteor in 2013, a larger rock explodes mid-air with the energy of a nuclear bomb. Windows shattered across Russia. 1,600 people were injured, but no crater was left behind. The moon, by contrast, has no such shield. Every grain of dust, every tiny pebble, smashes into its surface at full speed, leaving permanent scars. Earth's atmosphere filters out billions of small impacts, leaving our surface far cleaner. But what about the monsters? The 10-kilometer asteroids, the mountain-sized killers? For them, the atmosphere is tissue paper. They smash through with ease. They should leave behind scars hundreds of kilometers wide. Where are they? The atmosphere explains why small craters are rare, but what about the big ones? Here enters the second suspect: erosion. Water is relentless. Rain falls, rivers carve valleys, oceans pound coastlines. A fresh crater fills with lakes and streams. Sediments pour in, smoothing the jagged edges. Plants take root, their roots prying apart fractured rock. In the tropics, this process is even faster, with humidity and storms accelerating decay. Take Meteor Crater in Arizona. Over a kilometer wide, it looks fresh, yet it's 50,000 years old. Why does it survive? Because Arizona is dry. Rainfall is scarce, erosion minimal. In wetter climates, such a crater would have been softened and filled within a few 100,000 years. Then there are glaciers. During ice ages, sheets of ice kilometers thick bulldozed landscapes, grinding mountains into rubble. Any crater in their path was scoured flat. Wind also plays its role, sandblasting exposed surfaces in deserts, reshaping rock grain by grain. Over millions of years, even massive impact structures fade into subtle depressions. The moon has no rain, no rivers, no glaciers, no wind. Its scars are eternal. On Earth, scars are temporary. Erosion alone explains why countless craters, especially the smaller ones, are gone. But erosion cannot erase them all. Some impacts were too vast, too catastrophic to simply wash away. To explain those, we must dig deeper. Now we come to the most ruthless eraser of all: plate tectonics. Earth's lithosphere is broken into plates that drift across the surface. They collide, pull apart, and slide past one another. This constant churning has shaped mountains, continents, and oceans. But it also acts as a recycling machine. When oceanic crust collides with continental crust, the denser ocean floor is forced downward into the mantle. This process, subduction, destroys everything on that crust, including impact craters. The entire ocean floor is recycled every 180–200 million years. Compare that to the moon, where surfaces are over 3 billion years old. The moon preserves ancient scars. Earth constantly renews itself, erasing them. Even on land, craters are twisted, buried, or obliterated by tectonic motion. South Africa's Redefort crater is over 2 billion years old, but today it is so eroded and tectonically altered that only its deep roots remain. Canada's Sudbury Basin, once a colossal impact site, is now a deformed oval after billions of years of geological stress. Plate tectonics is the ultimate cleaner. It doesn't just hide craters, it annihilates them. If Earth erases craters so efficiently, how do we know they existed at all? Here, science becomes detective work. One clue is shocked quartz. Under the unimaginable pressures of an impact, quartz crystals deform in a unique, cross-hatched pattern. Finding shocked quartz is like finding a fingerprint of catastrophe. Another clue is shatter cones, cone-shaped fractures in rock that always point toward the center of an impact. Scientists also hunt for spheral layers, tiny glass beads formed when an asteroid impact vaporized rock, flung it into the atmosphere, and let it rain down worldwide. Such layers, billions of years old, have been found in South Africa and Australia. They testify to impacts whose craters no longer exist. And then there's Chicxulub, the most famous ghost crater. For decades, geologists puzzled over the iridium-rich clay layer dating to 66 million years ago, evidence of a massive asteroid. But where was the crater? It was only in the 1970s, while searching for oil in Mexico's Yucatan Peninsula, that geophysicists discovered a buried circular anomaly. Chicxulub had been hiding under a kilometer of sediment, yet it was the murder weapon that wiped out the dinosaurs. By combining seismic imaging, gravitational mapping, and geochemistry, scientists today are uncovering hidden craters worldwide. From Canada's Manicouagan to Greenland's Hiawatha, the ghosts are slowly being revealed. From Canada's Manicouagan to Greenland's Hiawatha, the ghosts are slowly being revealed. There's another possibility, one that's more speculative but profoundly important. Some impacts may have been so colossal that they reshaped Earth itself. The leading theory for the moon's origin is the giant impact hypothesis. Around 4.5 billion years ago, a Mars-sized body struck Earth, ejecting debris that coalesced into our moon. That impact also tilted Earth's axis, giving us seasons. Other giant impacts may have delivered the water that fills our oceans, or the metals that fuel our industries. Earth's very identity, its geology, atmosphere, even its biology, may be the product of impacts whose craters no longer exist. The missing scars are not just holes in the ground. They are woven into the fabric of our planet. The missing scars are not just holes in the ground. They are woven into the fabric of our planet. The hunt for missing craters is a global endeavor. NASA has mapped near-Earth asteroids and impact sites with satellites. European scientists developed high-resolution gravity models to detect buried craters. Indian researchers, using the Chandrayaan missions and ground surveys, have analyzed lunar craters as analogues for Earth's lost ones. Russian and Canadian geologists have uncovered some of the world's largest impact structures, like Sudbury. This is a planetary mystery, and solving it requires planetary cooperation. And now let's step back. What does it mean that Earth erases its scars while the moon preserves them? The moon is a museum of memory, silent, still, desolate. It cannot heal, so it keeps every wound. Earth, by contrast, is alive. It heals, recycles, renews. Our missing craters are not a sign of weakness, but of resilience. If Earth were like the moon, frozen and scarred, life as we know it could never have flourished. It is precisely because Earth erases its past that it can sustain forests, rivers, oceans, and us. The missing craters tell us not just about impacts, but about survival. Earth doesn't just endure history, it rewrites it. So where are Earth's missing craters? They are not missing at all. They have been burned away by the atmosphere, eroded by water, wind, and ice, and recycled by the planetary conveyor belt of plate tectonics. They survive only as ghostly fingerprints, shocked quartz, shatter cones, spherules, and anomalies deep beneath the crust. The moon shows us what a world looks like when scars last forever. Earth shows us what a world looks like when it heals. And that is the real mystery solved. The smooth, living face of our planet is not evidence of a peaceful past, but proof of a world that refuses to be defined by destruction. And that is the real mystery solved. The smooth, living face of our planet is not evidence of a peaceful past, but proof of a world that refuses to be defined by destruction. You've been watching Infinite Archive, where we uncover the hidden chapters of the universe. If this journey into Earth's missing craters fascinated you, let us know what other cosmic mysteries you'd like us to explore. Don't forget to like, subscribe, and ring the bell so you never miss our next investigation. And remember, the story of Earth is not written only in its scars, but in its power to erase them. Until next time, keep looking up.